So we're going to be looking at Ncloth, which is the first module based on Maya Nucleus. Maya Nucleus is the new unified dynamic simulation framework that's been generated. And for this simulation, for this presentation, we're going to be looking at doing two simple cloth simulations. The first one that we're going to do is going to be a flag simulation of this piece of geometry. So the first step in this is to go ahead and create a cloth object from this piece of geometry. So now that we've generated a cloth object from that piece of geometry, if we start our playback, you'll notice that the cloth starts to drop down. So gravity's taking effect of that, and it's pulling it down onto the ground. What we need to do is we need to tag a couple of points on this to suspend it from this flagpole. This is a very, very simple process inside of Maya. All we have to do is go back to our beginning frame, grab a couple of vertices that we want to work with, and tag them into this flagpole. So we'll create a simple transformation constraint to do this. Now that that transformation constraint's been added into our simulation, if we replay it, obviously we're going to get a different look than we did the first time. So the cape, or the flag, is just hanging here on this flagpole. The next thing that we want to do is we want to look at some of the environmental parameters that go into this simulation. So we're going to go back to our beginning, and we're going to start to introduce some wind into our environment. So if we go to the nucleus node here, you'll notice that there's a wind speed parameter. And if we start to increase some wind speed on this simulation, something very interesting is going to happen. You'll notice that the flag starts to lift up. And this is because the nucleus framework has the ability to generate lift. It has an air model inside of it. This is really revolutionary technology. It's the first time that we've been able to calculate air as a pressure system. So that lift model gives us all the automatic look to this flag. So I don't have to add turbulence fields or do a very traditional workflow. It's calculated in an extremely realistic manner just by giving it a little bit of wind. Another thing that's been traditionally very difficult to do with cloth simulations is tearing fabric. And this has been addressed inside of Ncloth. What we want to do is we want to generate a teared piece of geometry here. So we're going to go ahead and just select some edges that we want to define as tear points. So I'll just paint a selection here across there. We'll get a nice chunk that's going to fall off, and we'll do another little line across here. And now all we have to do is click another button on our shelf to go ahead and define those edges that we've previously selected as tears. So now that we've done that, if we select those guys so that we can modify some parameters here, we'll play this back. Our cloth goes ahead and it starts to break apart. Now, for my simulation here, I don't really want it to break apart right at the very beginning of my animation. So I'm going to modify a couple attributes on those constraints that we just added, those tear constraints. Again, the thing to realize here is I'm doing this all in a very fast, real-time interactive manner. It's totally revolutionary. It's super cool. I love it. Get very excited about it. So let's go ahead and go back to our nucleus node. We'll zero the speed out. We don't want to have that flag blowing along. And what we're going to do is we're going to modify the glue strength. So it's got a very low value right now of 0.1. So it drops down and it tears. If we increase that value a little bit higher, and we replay back our animation or our simulation here, you'll notice that it's not tearing anymore. So we're going to make the simulation a little more complicated. We're going to add another object into our simulation here. We're going to take a boulder that lives back here, and we're going to use that boulder to bash this flag around a little bit. So this is a really fun part of my job. I get to destroy things and bash them around with rocks. Everyone should become animators, and you'd get to do this also. So what we're going to do is we're going to go ahead and we're going to define this boulder as a collision object. And now that we've done that, if we go back into our interactive playback mode, and we start that simulation again, and I start to take this rock and bash it into the flag, obviously everything happens in real time here, and if I really wallop it, there goes all my cloth pieces falling to the ground and fluttering realistically because of that lift model that lives inside of Maya Nucleus. So to finish this off, we're going to do a kind of similar animation here. We're going to take the string of flags that lives between the flagpole and the building here, and we're going to generate another cloth object in our scene. Same workflow that we just did previously. I create a cloth object from it. It starts to drop down and fall in a realistic manner. We want to have those flags collide with the roof of this building. So we'll grab that piece of geometry and we'll add another collision object onto it. Now if we play it back one more time, you'll see those flags come down and hit it and start to collide with it realistically. And what we want to do is we want to suspend these flags between that flagpole and this roof. So we're going to do another transformation constraint. I'm going to go ahead and grab a vertice on that flag there and add to my selection another vertice down here and do that same transformation constraint that we did previously. And now if we play back the simulation, obviously those two flags are pinned. They've been transformed constrained to those points in space. but those other 10 flags don't have a relationship between each other. So we need to add another constraint to build up a relationship between these different flag objects. This, again, is a very simple process inside of Maya. So we'll go ahead and we'll weld those objects together now. And if we play this back, obviously they're going to drop down here, they're going to blow around, and they're all joined together with this weld constraint. We go back to the nucleus node, add a little bit of wind into my environment, they're going to start to blow around. Maybe go back to the Ncloth shape, which is the flags here, and add a little more lift. They're going to start to flutter a little more chaotically. And all of the constraints inside of Maya work on the same approach. So the tear constraint had a threshold that got exceeded to make the tear happen. The weld constraint has the same type of attribute on it, called glue strength. So if we drop that glue strength down, the flags will break once a tension level is exceeded. So we'll go ahead to that dynamic constraint, and we'll just start dropping that glue level down, and there they go flying off. And they're going to swirl around and move the way leaves move because of this notion of lift. So they're actually looking at the profile shape of each cloth object and using that to generate its lift model. It's very, very fun, interactive technology. I'll hand it back to Mark. It's a brief overview of Ncloth and Maya Nucleus.